Hi, my name is Yanghong Simaka. Today I'm going to present my final project to you. In this Kaggle competition, my private ranking is 12. First, I load the package I need to use for this project. Then I load the training and test data. To better understand the data set, so I start looking the basic statistic of training data. Then I start do some data visualization of the data. This is the histogram of each feature. By look at the distribution of each histogram, we can see some skewness. So we should consider standardize or normalize the data. Also, I visualize the correlation matrix using heat map in SIBO. By look at the correlation plot, we can see some strong correlations and weak correlations between variables. So there are definitely some linear and non-linear correlations among those variables. I also draw the plot the overall distribution of each variables. By look at the plot of the overall distribution of each features, it tells me that there are some noises, especially the feature WD, this feature. By looking this graph, there's no pattern, so there's no information. So I start checking is there any missing values on training and test data. The answer is no. Then I start doing data pre-processing, like normalize the data, prepare the data for building model. Normalize the value can reduce the noise data and we can have more accurate predictions. So first I did is set training values as type flow 32. Then I start normalize the data set, use scikit-learn pre-processing standard scalar this function to fit and transform train and test data. Then I check the normalized training and test data's shape, like how many rows and columns in them. Then I start prepare the training data to be queries ready. From professor's reference, this link, it taught me how to convert a time series to a supervised learning problem. So this is the function from this blog, but I did add some to get what I want from this function. So what I did, then I start passing normalized training data to this function, and then it will return x train and y train. The x test data is the test data set. Then I start building the model. Before I build the model, it must reshape training and test vectors to three-dimensional. For our problem, number of data dimensions is equal to the number of features, which is 14, and time steps is equal to the number of hours in a day, which is 24. Then I reshaped the X-train and X-test to the shape we wanted, like number of sample, number of time steps, number of features. Because we only have a training and testing data, there's no validation data. So I take a 1/3 of X train, Y train to be my validation data by slicing 1/3 of it from X train and Y train. Then I start building the model. Model 13 is my best model. It has a simple architecture, like one LSTM layer and one dense layer. In this model, I used the Atom optimizer with learning rate 0.005, and the learning rate decay over each update is 0.001. For the last, I used the mean absolute error. Then I feed data into this model with batch size 64. And the validation data is a X test and Y test. Um, uh, this model on Kaggle is 0.53711, so it's my best model. I will explain why I got this. I picked this one as my best. I also tried on like stacking recurrent layers like this, and bidirectional LSTM, and even more complicated model. Um, Model 2 also is my simple model. Um, then I plot all the results from each model, and so I can easily compare which model is the best by looking their loss. So model 13 and model 2 is my top two models, but in the Kaggle actually it showed me model 13 is the best. I After I build the model, I start making predictions, and then I rescale the predictions back to the original scale. Sorry. Also calculate the mean absolute error of actual y and predicted y. Then I write the results. Then I load the sample submission file. Then write the prediction to the submission file. Thank you.